Hello everyone, and welcome. In this video, we'll be diving into the world of Power BI, focusing specifically on one of the most important concepts, advanced DAX and optimization. This session is brought to you by ZoomInData, your space for learning business intelligence and data analytics. So, let's get started and understand how Power BI connects to different data sources and why this process is so essential in today's data-driven world. First question. Explain context transition and give a scenario where it produces unexpected results. Context transition occurs when Calculate converts an existing row context into an equivalent filter context, allowing the measure engine to evaluate expressions using filters derived from the current row. This transition commonly happens inside iterators. Example SumX, where each row context is automatically turned into a filter context when Calculate or a measure is referenced. Unexpected results arise when developers assume that a row context alone filters data, but without context transition, the row context is ignored in measures. A typical surprise occurs when a calculated column uses Calculate and suddenly returns different values because the row context gets converted to filter context, making the result context dependent. Second question. How do nested iterators, like SumX inside filter, create multiple row contexts? Each iterator, SumX, filter, addcolumns, etc., creates its own independent row context, meaning multiple row contexts can be active simultaneously. In nested iterators, the inner iterator inherits the outer row context, creating layered row contexts that developers must mentally track. When a function like Calculate is used inside nested iterators, any of the active row contexts may be transitioned into filter context, causing complexity. Misunderstanding which row context is currently active often leads to incorrect aggregations or earliest confusion. Third question. Why does earlier sometimes fail, and what is the modern alternative? Earlier fails when there is no outer row context to refer to, which often happens in measures or inside expressions where DAX did not create multiple row contexts. It also becomes confusing in deeply nested expressions where earlier must reference the correct level of row context, making debugging difficult. The modern alternative is using var, variables, which store row values explicitly and avoid dependence on row context levels, making the code more predictable and readable. Functions like selectedValue or Calculate plus values also replace earlier by retrieving the intended row level value without relying on ambiguous context hierarchy. Fourth question. Demonstrate how Calculate converts row context to filter context inside an iterator. When an iterator like SumX iterates over rows, it creates a row context but does not automatically filter the table. When Calculate is used inside that iterator, it captures the current row's values and turns them into filters, producing results that depend on each row's data. Example. Inside SumX, Calculate sum sales amount will force the engine to filter sales by the current row of the iterator. This conversion is the core reason why SumX with Calculate behaves differently from SumX without Calculate. Fifth question. Give an example where misunderstanding row versus filter context leads to the wrong calculation. Writing a measure in the same way as a calculated column often gives incorrect results because measures use only filter context, while calculated columns use row context. A common mistake is creating row-level logic in a measure, like sales, quantity, multiplied by sales, price, expecting row-by-row evaluation, which does not happen without an iterator. Developers sometimes expect a calculated columns result to match a similar measure, but the measure aggregates across the filtered table, not row by row. Incorrect totals in matrices often arise when developers assume row context exists for measures, but filter context alone determines totals. Sixth question. How does filter context override versus intersect when using multiple conditions? When multiple filters apply to the same column, the latest filter overrides the previous one, meaning the earlier filter becomes irrelevant. When filters apply to different columns, they intersect, producing a combined, narrower dataset. Using calculate with multiple filter conditions forces the engine to evaluate column by column and apply overrides or intersections accordingly. Removing filters using remove filters or all except can change the override behavior and reset the filter context selectively. Seventh question. Why does a calculated column result differ from a measure using the same formula? A calculated column is evaluated in row context, meaning it runs row by row and does not depend on report filters or slicers. A measure is evaluated in filter context, which changes dynamically based on visual level, page level, or slicer filters. Measures are aggregated at query time, while calculated columns are computed during data model processing and become static values. Therefore, identical formulas produce different results because the execution context, row versus filter, fundamentally changes how DAX evaluates the expression. Eighth question. How do you debug context problems in a complex measure? Start by breaking the measure into smaller pieces using var variables, returning intermediate results to identify where the context shifts. Use functions like values, selected value, or is filtered to check what filters are currently applied. Temporarily remove filters using remove filters or all to test how context affects the output. Compare a simplified version of the measure in both a table visual and a card visual to see how row context and filter context behave differently. Ninth question. How can variables store tables, and why is this powerful? DAX variables can store entire table expressions, not just numbers or text. For example, var filtered table equals filter sales where sales amount is greater than 1000. Storing a table inside a variable allows you to reuse that filtered result multiple times without re-evaluating it, improving performance and consistency. Table variables make code more readable and maintainable because they replace long filter or summarize expressions with a simple variable name. They enable multi-step transformations, such as filtering followed by grouping followed by iterating within the same measure, allowing DAX to behave more like a pipeline. 10th question. What is the scope of a variable inside nested return statements? DAX variables only exist within the expression block where they are declared. They cannot be accessed outside their return block. Inner return blocks can access variables declared in the outer scope, but outer blocks cannot access variables declared inside deeper nested expressions. Variables follow strict lexical scoping, meaning their value is fixed after the return statement begins and does not change during evaluation. This scoping avoids naming conflicts and ensures predictable behavior, especially when dealing with multi-step logic. 11th question. How do variables behave inside SUMX versus outside SUMX? When a variable is declared outside SUMX, it is evaluated once before the iterator begins, and its value remains constant for all rows. When declared inside SUMX, The variable gets evaluated for every row of the iterator, meaning it is recalculated repeatedly with each row context. Variables inside SUMX can capture row-specific values, like sales, quantity, because they inherit the row context of the iterator. Choosing whether to place variables inside or outside SUMX can significantly influence both performance and correctness depending on the business requirement. 12th question: how can variables prevent repeated evaluation in expensive measures? Without variables, complex expressions, like filter over large fact tables, may be recomputed multiple times when referenced repeatedly in a measure. By storing such expressions in a variable, DAX evaluates the logic once, and the result is reused, reducing formula engine workload. This improves performance in scenarios involving heavy operations like SUMX, calculate with multiple filters, or nested filter expressions. Using variables ensures that complex intermediate steps do not cause redundant computations, making the measure more stable and predictable. 13th question: why should complex business logic always be written using variables? Business logic often requires multiple transformation steps, which become unreadable when written as one long DAX expression without variables. Variables help structure the logic into sequential steps, similar to a flowchart, improving clarity, debuggability, and maintainability. They allow storing intermediate results, like subtotals, flags, filtered tables, which can be reused later, avoiding redundant calculations. Using variables reduces cognitive load for both developers and reviewers, making the DAX measure more explainable to business stakeholders. 14th question: can a var inside calculate use the modified filter context? Explain. Yes, variables inside calculate are evaluated after calculate's filter context has been applied, meaning they inherit the new filter context. When calculate changes the filters, any variable declared inside its expression reacts to that updated context, not the original one. This enables dynamic calculations where variables depend on slicer selections or overridden filters inside calculate. It also allows writing measures that adapt to custom filter logic, such as calculating metrics for last year, last quarter, or custom segments. 15th question: write a measure where variables help avoid circular dependency. Circular dependencies occur when a measure references a calculated column or another measure that indirectly depends on itself. Using variables allows storing intermediate values before they are used in calculations, breaking the cycle of dependencies. Example: safe profit % equals var sales value equals total sales. var profit value equals total profit. Return divide profit value, sales value. By storing the measures in variables, DAX resolves their values independently before combining them, avoiding circular reference errors. 16th question: how do you debug a measure using an intermediate var return trick? Temporarily replace the final return with the name of an intermediate var to see what value it produces. Example: return step 2 result instead of return final result. This allows you to check the value of each step under the current filter context, making it easy to detect where the logic breaks. You can progressively uncomment or remove layers of logic until the source of the problem, usually a wrong context or filter, is identified. This debugging method is widely used in complex measures involving calculate, filter, and SUMX, allowing precise identification of context errors. 17th question: When does SumX force the formula engine and break storage engine optimization? SumX breaks storage engine optimization when its first argument produces a row-by-row iterator, forcing the formula engine to compute values individually for each row. If the second argument inside SumX references a measure or expression requiring context transition, VertEPAC cannot aggregate efficiently, triggering fai evaluation. SumX also forces fai whenever the table passed to it is not a simple physical column reference but a complex expression, filter, add columns, values, etc. As soon as the formula engine becomes responsible for computation, parallelism decreases and query time increases, especially on large fact tables. 18th question. Why is filter the slowest function in DAX, and when should it be avoided? Filter scans the entire table row by row, meaning it performs a full table scan even if only a small portion of the table qualifies. Because filter generates a virtual table, it cannot benefit from storage engine optimizations like segment elimination, causing more work for the formula engine. Filter becomes extremely slow when used on fact tables with millions of rows, especially inside nested expressions like SumX or calculate. Filter should be avoided when a simple Boolean expression inside calculate can achieve the same result. For example, fact amount is greater than 1000. 19th question. Why does removing columns from a table improve performance? Each additional column increases the size of the storage engine segment, reducing VertEPAC's ability to compress the table efficiently. High cardinality columns, such as text or timestamps, drastically reduce compression, increasing memory usage and slowing down scans. Removing unused columns reduces the amount of data scanned during DAX queries, speeding up both the formula engine and storage engine operations. Smaller tables improve auto-aggregation, caching, and query folding, resulting in faster measures and visual responsiveness. 20th question. Explain how context propagation affects performance in nested filters. Each nested filter creates a new iteration layer, and each layer must evaluate the filter condition for every row, multiplying complexity. When filters depend on each other, the formula engine must compute intermediary virtual tables, increasing CPU usage. Deeply nested filters prevent the storage engine from performing optimized operations like columnar scans or segment elimination. This results in slow-performing measures that scale poorly as data volume grows, especially in complex financial or time intelligence calculations. 21st question. When should ADD columns be avoided for performance reasons? Add columns should be avoided when used on large fact tables because it constructs a virtual table with additional columns for every row, dramatically increasing memory usage. It becomes even slower when expressions inside ADD columns include measures or calculate, forcing row-by-row context transitions. Add columns blocks some storage engine optimizations, causing the formula engine to process intermediate tables. It should be replaced with summarize columns, or variables when the purpose is grouping or lightweight transformation. 22nd question. What DAX patterns guarantee poor performance regardless of hardware? Using filter over fact tables inside iterators like SumX or earlier ensures row-by-row processing that does not scale. Creating virtual tables with ADD columns plus filter combinations, especially when referencing complex measures or lookup columns. Overusing nested calculated columns instead of measures leads to bloated models and unnecessary memory footprint. Using distinct OR values over large fact tables inside calculate guarantees heavy formula engine operations and slow queries. 23rd question. How does VertiPack compression influence DAX optimization choices? VertiPack achieves maximum compression when columns have low cardinality, so using integers, categories, and surrogate keys improves performance. High cardinality columns, such as text, timestamps, or GUIDs, reduce compression, increasing scan times and decreasing storage engine efficiency. Choosing to pre-aggregate or split columns, for example date into year, month, and day, improves compression and accelerates DAX queries dramatically. Understanding compression behavior helps modelers decide which columns to keep, which to split, and which to eliminate entirely for optimal performance. 24th question. How do you break a long, multi-step measure into smaller, helper measures? Breaking a long expression into helper measures improves readability because each step becomes independently understandable and testable. Helper measures allow you to validate intermediate logic using cards or tables, making debugging significantly easier. Reusing helper measures prevents duplication of logic across visuals, improving both performance and maintainability. Complex business logic becomes modular, enabling other team members to modify or extend individual components without touching the entire calculation. 25th question. Explain measure branching and why it is crucial in large dashboards. Measure branching refers to building one measure on top of another, creating a logical tree of reusable DAX components. This approach prevents repetition of expensive calculations and reduces the chance of inconsistencies across multiple visuals. Dashboards become faster because intermediate steps are computed once and reused instead of recalculated. Branching also increases transparency. You can trace any complex KPI back through its upstream measures to understand its logic. 26th question. How do you write a single measure that adapts to any granularity, such as day, month, or quarter? Use is in scope or has one value to detect the current grain and apply the corresponding logic dynamically. The measure should return aggregated values using functions like sum, average x, or calculate based on the detected level. This eliminates the need to create separate measures for daily, monthly, or quarterly views. Performance improves because the logic is handled in a single optimized calculation path rather than multiple redundant measures. 27th question. How do you design a DAX expression that changes its logic based on slicer selection? Use selected value or values to detect the slice's selected option and branch logic using switch followed by true. Each branch can apply different filters, aggregation logic, or calculate expressions depending on the business requirement. This approach gives users flexibility, since one KPI measure can act as average, median, or percentile based on what they select. It avoids creating multiple separate measures, reducing clutter and improving maintainability. 28th question. How do you debug a deeply nested calculate expression? Convert pieces of the calculate logic into separate var blocks and return them temporarily to verify intermediate results. Remove filters step by step and validate how the output changes to identify which filter or condition is causing the issue. Add return statements that output intermediate tables using DAX Studio's query view for inspection. Use tools like Performance Analyzer, DAX Studio Server Timings, and the conceptual filter propagation tree to trace the flow of filters. 29th question. How do you handle a scenario where YTD, rolling total, and year-over-year must work in one single measure? Use dynamic time intelligence with a slicer-driven option table and switch followed by true to decide whether to return YTD, rolling 12 months, or year-over-year. Build reusable base measures like total sales, YTD sales, rolling sales, and year-over-year growth to plug into the switch. Ensure the measure detects the current date context correctly using date add, same period last year, or dates YTD. This single measure approach maintains consistency across visuals and supports flexible user-driven insights. 30th question. Explain how disconnected tables simplify complex calculations. Disconnected tables allow you to control logic purely through slicer selections without altering the core data model relationships. These tables work as parameter tables, enabling dynamic switching of metrics, time frames, currencies, or business rules. They prevent relationship conflicts and ambiguity, especially in models with multiple fact tables. Calculations remain clean because you branch logic inside switch followed by true based on the selected value from the disconnected table. 31st question. How do you implement tier-based logic, such as tax slabs or discount slabs, cleanly in DAX? Use a tiers or slabs table, often disconnected, that defines ranges and corresponding rates for each slab. Apply a measure using SUMX over the slabs table to compute the applicable rate for each portion of the amount. This avoids hard-coding logic in switch statements, making the calculation dynamic and maintainable. It also allows business teams to update slab values directly in a data table instead of modifying the DAX code. Thank you for watching this session. If you have any questions, you are welcome to contact ZoomInData through our website, email, or phone. We're always here to support your learning journey. See you in the next video.